A small fun fact for you. One of the main reasons ISRO is able to send rovers to the Moon and the Mars at such low expenditure. Hey everyone, today's video will be a bit different. We will not be discussing a paper. Instead, I will be talking about animation versus physics, an amazing video uploaded by one of my favorite YouTubers, Becker. To be precise, I will be sharing my favorite moments about the video with you. I can't discuss every single physics concept involved because I don't want this video to be too lengthy. Alright, without further ado, let's begin. The first moment that I would like to talk about is the conservation of energy principle that is showcased very subtly here. He wants to reach the other side to get the rope, but the boulder is blocking his path, so he pushes it forward. The boulder starts rolling down and reaches point B here. The TSC also slid down the incline and tried his hardest to reach the top, but could not. Why did that happen? I think you should take some time to think about it for yourself. He could not reach because he started to slide down from a lower point than what the boulder did. Take a look here. The boulder started from a height that is equal to the height of its final position. It had enough potential energy to be converted into kinetic energy. The TSC started from a lower point, hence he had enough energy to reach only a proportional height and not the top. He reaches the top the next time because he uses the rope and the tree to give himself an extra amount of potential energy, which is then converted into excess kinetic energy, thus not only helping him reach the top but also slide forward for a few seconds. Beautiful. This is by far one of the cleverest moments in the entire video. The TSC swings off the tree branch to launch himself off towards the rocket. What is the physics principle behind this? Think. It's the conservation of angular momentum. Let's observe what's going on here. As the boulder, which is tied to the branch of the tree, rolls down, the radius of the circle of rotation is decreasing. Let's do some very basic math to understand in slightly more detail. Please don't get scared. Angular momentum basically represents the rotational motion of an object and is the product of the moment of inertia of the object and its angular velocity. The moment of inertia is the product of the mass of the object and the square of the distance from the axis of rotation. Let's take two moments in time and acknowledge the fact that since there are no external forces or torques involved, the angular momentum of the system remains constant. This means that we can equate the two angular momentum quantities and observe that as the radius of the circle of rotation decreases, the angular velocity of the TSC increases, giving him enough velocity to slingshot off towards the rocket. I found this to be such a clever way of utilizing that concept, and I had to share that with you. Oh, and by the way, this is the exact reason why ice skaters start to spin faster when they fold their hands in. To conserve angular momentum, the angular velocity must go up. There is nothing spectacular going on here when compared to the previous two, but I thought of talking about it here because this moment sets up a concept that will be prevalent for the rest of the first half of the video. The Lorentz Factor is an important component of Einstein's special theory of relativity. It gives a relation between the velocity of an object in motion and the speed of light. Note that the velocity of the object can never be equal or greater than the speed of light, because if it does, then we get undefined or imaginary numbers as answers, which does not really make much sense in the physical world. After leaving the planet the TSC originally landed on, he eventually sees the other neighboring planets and the host star, which seems like a red giant. The red giant phase is the next stage in a star's life after its main sequence journey. To leave the star system, the TSC uses a very clever maneuver, the Gravitational Slingshot. Without wasting extra fuel to escape the gravitational pull of the planet, he instead uses gravity to give him the extra boost he needs to escape at the right moment. He does this a couple of times and finally attains a beta of 1% to leave the star system. A small fun fact for you. One of the main reasons ISRO is able to send rovers to the Moon and the Mars at such low expenditure is because they utilize the gravitational slingshot maneuver extensively to save fuel. While watching this segment, I had to admit that TSC is a very smart character and can adapt to any situation. To further increase his velocity from 1% the speed of light, he has the following objects to aid him: a magnet, a rocket, a bar, and a series of massive magnets with strong magnetic fields. How does he accomplish his goal? Think for a while. And while you think about the answer, maybe you could like this video and subscribe to my channel. It would help me accelerate my YouTube channel to higher velocities. Here's what he does. He first magnetizes the rod by rubbing the magnet on the rod's surface, which polarizes the atoms. This is magnetic induction. He then wraps the rod around the rocket, turning it into a solenoid, which increases the magnetic field of the entire system. The massive magnets in front of him then pull him inward and accelerates him away. Finally, he reaches a beta of 80%, which is enough to bring in the next set of effects that I will discuss in a few moments. But before that, I wanted to mention 2 points. The concept shown here is the same concept involved with a magnetic railgun, where a bullet is accelerated to high velocities by a series of electromagnets. There is a small mistake with how the magnetic railgun was shown in the video. Do you know what it is? Comment your answer down below and let's discuss. A beta value of 80%, which means that he is traveling at 80% the speed of light, is enough for relativistic effects to show up, 2 of which are shown here. Time dilation is an effect predicted by Einstein's special theory of relativity. When 2 objects are in motion relative to each other, then time can pass at different rates for the 2 objects. This is the equation that describes this phenomenon, and as you can see, the Lorentz factor has popped back up here. Length contraction is another consequence of Einstein's special relativity, according to which the length of a moving object seems to be contracted along the direction of motion as observed from a stationary point of view. This is the equation that describes this effect, and yes, the Lorentz factor is here again. Doppler shift is an effect that is ubiquitous throughout astrophysics and is a light analog of the Doppler effect of sound waves. When an ambulance is passing by you, if you pay close attention, you will notice that the frequency of the sound increases as the ambulance is coming towards you and decreases when it is receding away from you. This happens because as the ambulance is moving towards you, the sound waves need less and less time to reach you, thereby decreasing the wavelength of the waves and increasing the frequency. When it is going away from you, the waves now need more time to reach you, thereby decreasing the frequency. Since light is an electromagnetic wave, the same phenomenon can be observed here. When a luminous object is moving towards you, the light waves need less time to reach you. This decreases the wavelength, which makes it shift up towards the bluer end of the electromagnetic spectrum. This is called blue shift. The opposite happens when the object is moving away from you. The wavelength of the wave decreases, shifting it downwards to the red end of the spectrum. This is called redshift. Another fun fact for you, the earliest evidence of the expansion of our universe came from the application of the Doppler effect. We have another interstellar moment when the main character finally reaches the enigmatic creation of nature, the black hole. Let's unpack some of the terms here. Relativistic jets are jets of particles traveling at speeds very close to that of light. The reason they reach such high velocities is most likely due to the extreme gravitational and magnetic fields found near the vicinity of a black hole. An accretion disk is a swirling, flattened collection of gas, dust and other materials that are spiraling towards the center of the black hole. Due to the extreme environments, the matter is compressed, making them emit intense radiation. He finally reaches 99% of the speed of light, and now we have a lot of terms to unpack. The reason the accretion disk is appended by far side is this. The path of the light that is coming from behind a black hole is bent by a black hole's enormous gravitational fields. That is why we can actually see what's behind it. This phenomenon is called gravitational lensing. The event horizon is a limit beyond which nothing can escape from the black hole's gravitational field. That's why it's black. No information reaches us from behind the horizon. Doppler beaming can be considered to be the next stage of Doppler effect, where the light emitted by the fast-moving material around the black hole is compressed in the direction of motion. This makes the emitted light more intense and bright in our direction. A photon ring is a result of an effect that I had talked about a few minutes ago. Due to the intense gravitational field, light or photons circle the black hole, creating a ring-like structure. The singularity is the center of a black hole with intense gravity, severely bent spacetime, and a point where our laws of physics completely break down. Phew, those were a lot of points. Moving on. Just like Cooper in Interstellar, the TSC decides to enter a black hole, and a very fascinating concept is shown here. I would like to bring to your attention that the main reason why we are able to see the character approach a black hole is that the light from him is reaching us. But as it gets closer to the black hole, the strength of the gravitational field increases. This makes it difficult for the photons to reach us since they have to expend energy to escape the pull. This decreases the energy thereby increasing their wavelength and causing them to redshift. One point will come when no photons from the character can reach us, and from our outside perspective, it will look like he has suddenly disappeared, while from his inside perspective, everything is fine and he is falling peacefully towards his doom. Here, the TSC is shown to be stretched along the direction of motion when he falls from a rocket. This is called spaghettification and happens due to the intense gravitational field present there. In such environments, 2 points, even with the smallest of separation between them, will experience a large difference in the pull. The feet of TSC is feeling a stronger pull than his hands, which is why he is getting stretched along the direction of motion. Oof, that must be a messed up feeling. The TSC suddenly starts to shrink here after crossing the inner horizon of the rotating black hole, but I am not sure why. Please let me know in the comments about it. But we get to come across quite a few interesting concepts as it shrinks down smaller and smaller. Parenchyma cells are plant cells that make up various organs and tissues in plants. Chloroplasts are plant cell organelles containing chlorophyll and help in photosynthesis. Mitochondria are the powerhouse of the cell and play a crucial role in energy production. Cytoplasm is an essential fluid containing organic and inorganic molecules. Endoplasmic reticulum is involved in protein and lipid synthesis. The cell wall surrounds the cell and provides rigidity and shape to the cell. The nucleus is the boss of the cell, containing the genetic material of the cell and responsible for all cellular processes. The chromatin contains the DNA, RNA and protein and is mainly responsible for gene expression and regulation. The DNA is the genetic material of the cell and contains instructions for the myriad of processes going on in the body. We then come across the fundamental particles of the universe, the electron, quarks, antiquarks and neutrinos. The TSC then enters a region that's studied by the string theory, a theory which posits that the fundamental matter of the universe is not made by point-like particles but one-dimensional strings of energy, and when they vibrate at particular frequencies, they give rise to the particles that we know and love. And this is it. Thank you so much for sticking with me throughout this journey. I hope you had as much fun as I had while watching the video and making this one. Please go ahead and watch Alan's new masterpiece. Comment down below your favorite moments and we can engage in a fruitful discussion. If you enjoyed watching the video and learned something new, please like the video, share it with your friends and family, and please subscribe to the channel because your support and enthusiasm for science keeps me going. Thank you, stay curious.